All right, let's do 663. It's interesting. Reminds me of that thing at McWayne Center where you can sit on different chairs and pull yourself up. It's basically a block and tackle. And you're holding up a weight, and the question is, what's P? And a couple of things. Again, we showed in earlier problems that for a pulley, it's in static equilibrium. If you sum the torques about the origin, the different sides of the rope have to be equal. Because you just got TR on that side, minus TR on that side, cancel the R. So those tensions have to be equal. So I've got, excuse me, for example here, I've got rope coming, it's attached to the center, coming down. So these two ropes have to be equal. And then there's a pulley here, so those two ropes have to be equal. So essentially all three of those have to be equal. And I've called it TC. So I call that R and TC. The same thing on the next pulley. Those two have to be equal. And then because they go through a pulley, those two have to, so they're all three equal. So that's all the way down. So I've sort of used that abbreviation in my free body diagrams, or use that idea. And then down here, for example, that pulley, again, those two are equal. And so we got that down and that up. So they're going to, you know, if I did a free body diagram, which I probably should have, but I'd have that force down and those two up. So they have to be equal. So I've used that here. So since that rope is TC, it's 2TC. That rope is TB. Because of the pulley, there's 2TB and 2P here. So there's sort of a lot of implied stuff in these free body diagrams. You could have drawn at least three more to get that point. But given that, I think these are kind of the minimum set we need. Then if I start here, sum up the forces, and I know that, well, first I have 50 kilograms, so I calculate the weight. And then actually I started on the mass here, and so I've got the weight down, 2TP, 2 and 2C. And then I'm going to come back to this one. I want to start at pulley A, and I got TP up and 3P's down. So sum of the Y's equals 0. That gives me TB equals 3P. And then I can go here. I got TC up and 3TP down. So TC is 3TB, but TB is 3P. So that gives me TC is 9P. So in other words, I can get these two in terms of P. I substitute them in. 2P, 2 times TP, 2 times TC. Gives me 18 and 2 is 20, 26P. So the weight here is, or P is 26 into the weight. Divide the weight by 26. Because each three, so how many? Okay, you can see how that worked because of how they're connected. Again, if you start here, work your way down, then you can substitute in and you can get the weight. And then I went ahead and calculated those two. And then I said, let's check. So if I start with the free body diagram of pulley A, then I get R and 3TC down. So R is 3TC. And then if I do this as a whole, I've got R up, I've got P down and the weight down. R up, P down, weight down, that does add to 0. So a lot buried in there. The fact that's connected to the center and the rope goes over a pulley meant all three of those are the same. So I went ahead and drew my free body diagram using that, cut down my number of unknowns. I basically had 1, 2, 3 equations and 3 unknowns to solve it. So that's the trick on pulleys, is to draw a free body diagram with a pulley. You've got support of the center, and then you've got what's coming off the pulley. And again, because we're in static equilibrium, then ropes and chains and belts across pulleys just change the direction, not the magnitude of the tension. Okay? If you have any questions on that, shoot me an email.